Hi there, and welcome to the final lesson in our simultaneous equations series. This is going to be a short lesson to show you how you can use the skills you've learnt in elimination and substitution and put them into use in answering questions. The most common question I get asked is when to use which method, and the answer to this is you need to know both of the methods fairly well, because as I showed in my last question in the elimination video, you can solve a lot of questions by elimination and substitution, and it's really a matter of preference, but you need to be able to do both. I'm going to show you now certain questions that kind of lean more towards a certain method than another. So looking at question A, we've got equation 1 and we've got equation 2. Remember that no matter whether you're eliminating or substituting, you need to label your equations. Question A jumps out at me as a clear elimination target. And let me tell you why. I've got 2x minus 5y equals 7, 4x minus 3y equals 4. I can clearly see I can make the x variables the same. I can make them both 4x if I multiply this top equation by 2. Or I could make the y variables the same by multiplying by 3 and then multiplying by 5. Yeah? So this is a clear elimination target. Let me explain why you couldn't do substitution here, or why it would be very difficult for you to do substitution here. 2x minus 5y equals 7. Looking at equation 1, this seems to be the easier equation. If I wanted to isolate one of the variables, x or y, it would be difficult, because I would get 2x and then I have to divide everything by 2, but 5 and 7 are odd, so then I'd have fractions and it would all be a bit of a nightmare. It's definitely doable, but it's just much cleaner to do this the elimination way. Moving on to question B, let's have a look at this one. Pause the video and have a think about what you would do. Would you eliminate or would you substitute? Question B for me is quite a clear Question B is quite a clear target for a substitution, and let me tell you why. That's because we've got an x on its own here. So that means I could easily isolate this variable and change this into x equals 26 minus 8y, and then any time I saw an x in equation 2, I would just write 526 minus 8y plus 2y equals 16, and you could quickly go from there without having to think about your elimination and what you multiply by. But you can see in this question, this is not the only way to do it. I could also do the elimination method. I could multiply this top equation by 5 and get 5x plus 40y equals 130, and then go from there and then take away. That would also be another way to do it. So this question is one where you could do it both ways. Looking at question C. Now this question is a very, very clear substitution question. Why? Well, because they've actually done the first step of substitution for you. The first equation says y equals 2x plus 1. That's already isolated your variable. You know that your magic equation is y equals 2x plus 1. So all you actually have to do is sub into equation 2, and you can do x plus 2, 2x plus 1 equals 17, and then you would have very quickly solved for x. So I hope this video has been slightly helpful in showing you the tips and tricks in deciding whether you want to eliminate or substitute. So try and think of, when you look at the equation, can you see a clear way to multiply to make one of the coefficients of the variables the same, as in question A? Or is there a clear way to substitute? Have they already done the first step for you? Or is there a single variable like these that you could clearly isolate? Think of these things when you're next doing your simultaneous equations practice, and try to get good practice of doing both. So you can see the attached worksheet that we've developed for you, and it has a range of questions that require substitution and elimination. So definitely get practicing, and if you have any questions, don't hesitate to let us know down below. Thank you for watching.